Production face environmental risk minimization in coal and lignite mines. There are still many coal mines in operation in Europe. They employ a lot of people and want to be more and more environmentally friendly. Coal formations were generated about 300 million years ago, when plant debris slowly changed into coal. But in those coal formations there is also methane gas, and methane is dangerous for people, environment, and methane accidents represent economic losses. In the 21st century, methane was the cause of over 62% of serious accidents in Polish mines. Methane emissions from operating and abandoned coal mines accounted for up to 10% of total methane emissions. Methane is the second most important greenhouse gas after carbon dioxide. Safety regulations impose monitoring of methane concentration in critical points. When this concentration exceeds the safety threshold, the electrical power is shut down at the Longwall district. After making sure that safe conditions have been restored, production may be resumed. However, emergency power shutdowns caused by excessive methane levels lead to huge losses. During the standstills, methane is released in an uncontrolled way. Solution: to develop a closed-loop system to monitor the Longwall environment. Methane emission, ventilation, drainage systems. Control or regulate coal production and machine operation schedule. 2. Eliminate excessive gas emissions. Mitigate against risks at the face. At Longwall and LTCC faces. We have created a pan-European consortium to take advantage of the synergy of knowledge and experience of many companies and institutions. Thanks to this, the effects of the project meet the highest expectations. The project was divided into several phases: collection of data, data analysis, modeling, Longwall control system development, testing Longwall control system. The collected data, analyzed, were used to create a numerical model of hazards resulting from the presence of methane in the excavation. Actual field testing of the shearer control system must be preceded with a research to be sure of its proper operation in a dangerous environment. Underground testing of the control system requires the necessary ATEX certification and length approvals through the relevant national authorities in each country. Getting such approvals is not possible within the 3 years project duration. That is why PICTO is a pre-competitive research and technological development project, rather than a demonstration pilot project. In PICTO, the control system has been developed and tested on so-called virtual longwall models. The virtual longwall models may be considered as a kind of a digital twin of the district on an underground mine. Those models are a variant of the VentGraph mine ventilation network computer simulator. A calibration of this simulator upon a field data has guaranteed the twin's identity. Then most of the real mine testing may be replaced with experimenting on its digital twin. The results of numerical calculations of changes in the distribution of methane concentration and air velocity values are comparable with the results of in situ measurements, which confirms the correctness of the assumptions made for the numerical model developed. The carried-out numerical simulations confirm the significant influence of the shearer's location on the distribution of changes in methane concentration in the longwall working, and thus has a direct impact on the gas conditions in the longwall working space. In parallel with the longwall systems modeling, a method of implementation of the control system into the hardware and software of the Eichhoff shearer has been developed and tested, turning the virtual longwall model into an optimal control demonstrator. Multiple simulations of the impact of longwall shearer on the extent of methane hazard allowed for development and tuning the shearer closed-loop control system. Its performance has been compared with the standard modes of operation to assess potential benefits of the controlled operation. Both classical single-slice longwalls and the top coal caving method for the thick lignite seams have been considered. Computer simulations have shown that although the control system occasionally slows down the shearer considerably when the trends in methane concentration are unfavorable, these limitations do pay off, as the flexible cutting velocity settings allow to accelerate when it is possible and protect from the losses generated by the methane-related emergency downtimes. As it has been planned, the results of PICTO lay a firm ground for a future field testing of this methane hazard prevention method. Summarizing, the use of the controller allowed for higher production, while limiting the release of methane into the atmosphere. After ATEX certification and underground trials, implementation of this system in the production machinery will be a fully innovative approach to the automation of longwall operations in methane hazard conditions, aimed at increasing productivity and safety by reducing the number of accidents and emergency downtimes, limiting the presence of the crew in the longwall district, limiting the negative environmental impact of the uncontrolled release of methane from coal mines, and reducing the strain the operating components of both the longwall shearer and the armored face conveyor experiences due to regular stop-start processes at the face.